Hi everybody, as promised I'm making a short video for you to introduce some of the concepts of pathology or paleopathology, that is disease in human skeletal remains. You have some good information in your textbook, but your textbook is going to focus primarily on the forensic side of the study of disease in the skeleton, which is ruling out things that may be mistaken for trauma and identifying things that might contribute to making a personal ID. We actually can learn a lot more about a skeleton and disease than just that, but that's typically the realm of bioarchaeology, because in bioarchaeology we're interested in creating life histories for people in the past, and that is learning all we can about how they lived in their culture. In forensics, it's not really a study of the people like that. The goal is to figure out what happened to them and figure out who they are, and that's it. They're not research subjects in this fashion. So I'm going to try to provide a little bit more information about the study of disease in skeletons through the PowerPoint and through this short video introduction, which should go along with the slides in your PowerPoint. I'm doing this in video format in part because I'm just so used to talking about this in class, and I feel like maybe I'll do a better job if I give you a little bit of a verbal presentation. So when we're talking about diseases in skeletons, we're not talking about any and all diseases that you might contract in your lifetime and how they would show up. The reality is most diseases that you contract or that anyone would contract during their lifetime does not impact the skeleton. That's because your common cold or flu passes through your system much too quickly to impact the skeleton. Remember, we're talking about bone changes taking years to build up. So that means conditions that impact the skeleton need to be chronic or non-fatal so that you live with them for a very long time. There are a couple of different conditions that can cause this, and we're going to talk in broad categories here. So things like certain infectious diseases, again, not the common cold, not the flu, but something like tuberculosis, which you can live with for many, many years. Metabolic diseases, those are diseases of deficiency or excess. So think of vitamin deficiencies like vitamin D and rickets, or vitamin C and scurvy. Congenital conditions, these are conditions with which, conditions that you are born with. So these are something passed from mom to baby. They could be defects, they could be certain congenital versions of infectious diseases. And neoplastic conditions, these include things like cancers that cause bone growth. Importantly, there are a series of reactions that the skeleton can have to an insult from a disease, but there are only basically 3 ways bone can react. And because of that, most of the conditions that we identify in skeletons, we cannot connect to a specific singular disease. All we can record is the bony reaction. There are a few that are diagnostic, and I'll mention those, but most are not. And the final main consideration for disease in general is to remember that disease is not just biological. Disease is socio-cultural and socio-economic. So what diseases you're exposed to depend on your activity, who you interact with, what you do on a day-to-day basis, what food you have access to. So for those who study life in the past and are looking to analyze how people lived and what their experiences were like, disease is an amazing category because it tells us so much about how the person was living. And we're acutely aware of this right now, right? Even just in a general sense, we know that one of the main ways we're trying to prevent the spread of COVID-19 is social distancing. If it was just purely biology, our social behavior would have nothing to do with it, but it spreads through interaction between people. So yeah, disease is a great marker of behavior. So in terms of paleopathology, like I said, it's the study of suffering, and it's the study of disease in the body, and it's the study of it in the past. And I mentioned to you that there are basically 3 main ways that the disease can impact the skeleton. It can cause lytic lesions, it can cause proliferative lesions, or it can cause deformation, or a combination of the 2. So what is a lytic lesion? A lytic lesion is one that causes abnormal bone loss. So remember osteocytes and osteoclasts and osteoblasts and all that, you get bone destroying bone, bone rebuilding bone, and all of that. This is what we're talking about here. Some conditions will cause abnormal bone loss. That is, bone will be taken away and not replaced at the same rate. And so you end up basically seeing holes, small, microscopic to large, big pockets in the bone. Proliferative lesion cause excess bone growth, overstimulates the bone cells to build. And so you see a buildup of bone on the cortical bone or internally densification. So this is proliferation. And deformative causes bone to change shape. And it usually involves some bone loss or some bone growth or both as part of that process. I'll include in the PowerPoint, I'm just sort of looking at my PowerPoint as we go, some drawings that are okay to explain some of these things, but again, I'll have to remove some of the pictures. Now, I mentioned that there are specific conditions that we can identify, and I'll give you a list of some of them in the PowerPoint, and you can use that list to look at some of these web resources I'm finding for you. But some conditions do cause a specific pattern of bone loss or bone growth, so lytic or proliferative lesions. One example is venereal syphilis. Venereal syphilis is a sexually transmitted disease. And for whatever reason, among the things that it does to the body in late stages, it can cause an excess buildup of bone growth along the tibia. They call it saber shin. You get this extra dense layer of cortical bone, periostitis basically, on the tibia. So if you see a tibia that has this very signature look to it, we know that it is a specific proliferative lesion, usually associated with venereal syphilis. Congenital syphilis, on the other hand, passed from mom to baby, interrupts the growth of teeth. And so on children, again, pre-treatment times, it would have been fatal. But children, what happens is the crown of the tooth, remember we grow from crown down to root, the crown of the tooth doesn't lay down properly. And so you end up, instead of having cusps on the molars, you know, those bumps and ridges, you actually have spikes. So if we see spikes on molars and teeth, we know that it is likely congenital syphilis. Rickets, my specialty, vitamin D deficiency, causes bone to be very soft and weak, and therefore it tends to bow under the weight of moving children. Vitamin C deficiency or scurvy, another one of my specialties, causes pulling away of muscle tissue from bone that causes hemorrhaging behind the tissue, which causes lytic lesions, and it happens in very specific places like behind the eye orbits where the gums are. Yeah, so you get the idea. I just wanted to offer you a few examples of diseases that we can diagnose because they do this proliferative or lytic thing in a very specific pattern. Some cancers are predictable. Prostate cancer and breast cancer, I've seen cases of both of those in bioarchaeological examples, and they have predictable patterns of lytic or proliferative bone lesions or both in those cases. There's one more really important concept, and then I'll wrap up this video, that I will put in the PowerPoint for you. And this is the concept called the osteological paradox. This is from some authors in 1992 who said that when we see skeletons in the past that have a lot of lesions on them, proliferative or lytic, what we are essentially seeing is if this is an adult who's lived to a decent age and has these skeletal lesions, we're seeing a healthy individual. Because in the past, pre-modern medicine, these sort of insults would happen to most people. I mean disease insults. And those who died from them with no evidence on their skeletons are those who died from those conditions quite rapidly. Whereas those who survived and survived long enough to have skeletal markers of it, including lots of skeletal markers of lots of diseases, are actually survivors. And so the osteological paradox basically says, for past individuals, not today, but for past individuals, the more lesions you have on your skeleton, the healthier you were as an individual, the better survivor you were. Okay, so those are just a few concepts for you that you will see in the PowerPoint as well. The last one is the osteological paradox, paleopathology and its relationship to diagnosable diseases, lytic versus proliferative lesions, and some particular conditions that we can see. It doesn't replace a whole lecture on all of this, but I hope that's some useful information for those of you who are interested in this topic. And like I said, look for those linked resources in the PowerPoint to see pictures and examples. Okay, good luck with all the work. As long as I've got you, why don't you say hi to Dusty too? She's hanging out with me this morning. Bye-bye.